State and prove the Lucca's theorem. Statement: if all the zero of a polynomial Pn lie in the half plane, then all the zero of the derivative Pn dash z lie in the same half plane. Now proof: if z1, z2 and so on zn are the zeros of p and z, then p and z is equal to an bracket starts z minus z1 bracket close comma into bracket starts z into z minus z2 bracket close so on bracket starts z minus zn bracket close. Now taking log on the both sides of equation 1, so we have this is 1, so log Pn is equal to log of square bracket starts an bracket starts z minus z1 bracket close bracket starts z minus z2 so on bracket starts z minus zn bracket close square bracket close. So which implies log Pn z is equal to log of an plus log of z minus z1 plus log of z minus z2 plus so on plus log of z minus zn. Now differentiating, taking both sides, we get Pn dash z upon Pn z is equal to 1 upon z minus z1 plus 1 upon z minus z2 plus so on 1 upon plus 1 upon z minus zn. Now supposing that the half plane H is defined as the part of the complex plane consisting of all the points of z that I am imaginary of z minus bracket starts z minus a upon b bracket close is less than 0. By given hypothesis zk is in the H, so that now imaginary of bracket starts z k minus a upon b bracket close, which is less than 0 for all k varies from 1 to so on n. Now let alpha be any 0 of Pn dash z. Then it satisfies to show that alpha in H. Let us suppose the contrary, then imaginary of bracket starts alpha minus a upon b bracket close is greater than 0. From 3 and 4 we have concluded that imaginary of alpha minus 3k upon b is equal to imaginary of square bracket starts alpha minus a minus bracket starts zk minus a bracket close upon b square bracket close, which is equal to imaginary of bracket starts alpha minus a upon b bracket close minus imaginary of bracket starts zk minus a upon b bracket close is greater than 0. Since imaginary of z is equal to minus imaginary of z minus z raised to power minus 1 plus modulus of z square for any complex number, and it is now follows from the 5 that minus imaginary of bracket starts b minus alpha minus zk bracket close modulus starts b upon alpha minus zk modulus close whole square is greater than 0, which implies imaginary of bracket starts b upon alpha minus zk bracket close is less than 0. Since 6 holds, it is good for all the k from 2. We conclude that imaginary of b upon p and b p n dash alpha upon p n alpha square bracket close is equal to sigmas varying from k1 to n imaginary of b upon alpha minus z k bracket close is less than 0. It follows that p n dash alpha does not equal to 0, which contradicts the fact that alpha is a 0 of p and z. So here all the zeros of p and z must lie in H.